Thank you for your interest in Decide Solutions Multi-CAD Collaboration webinar. This webinar was developed to provide information about SOLIDWORKS 3D Interconnect and how it enables SOLIDWORKS to directly open and repurpose files that are created in other CAD systems such as Inventor, Solid Edge, NX, PTC Creo, and CATIA when those files are saved in their native format. In the next 20 minutes, I'll provide more details about 3D Interconnect, then demonstrate how 3D Interconnect can directly open files and insert components into SOLIDWORKS assemblies, allowing you to design a product that will properly integrate and fit with components designed in a legacy CAD system or another preferred CAD system used by a supplier. First, the overview of 3D Interconnect. 3D Interconnect is a SOLIDWORKS technology that virtually bypasses the translation process with new workflows when working with native files from other CAD systems, allowing you to streamline collaboration with your customers and supply chains regardless of which CAD tool they are using. It would also allow you to leverage legacy data saved in their native CAD formats just as if they were native SOLIDWORKS files. 3D Interconnect is also intelligent and understands when CAD data has changed within the native design system. By honoring face and edge IDs, properties, sketches, and reference geometry, changes to those files are updated just like native SOLIDWORKS files. File formats utilized by 3D Interconnect can also open significantly faster than traditional import and export processes. 3D Interconnect is intelligent. It understands more than just traditional surface or body topology. Reference geometry such as planes, axes, sketches are included in the feature tree. These features allow you to reuse the same reference geometry from the native CAD system to properly locate components in SOLIDWORKS with mates, or to use geometry or layout sketches for critical to fit manufacturing features. When the file is changed in the native CAD system and updated, these intelligent features will update just like native SOLIDWORKS files. Also, custom properties and material properties are listed and can be used in bill of materials. The file formats that are currently supported by 3D Interconnect include PTC Creo, Autodesk Inventor, Siemens Solid Edge and NX, CATIA V5, and neutral file formats such as STEP, IGES, and ASCIIs. Common use cases for 3D Interconnect are anywhere there's a mixed CAD environment. In this webinar today, we're going to look at two different workflows to show you just how flexible working with 3D Interconnect and native CAD data can be. The first workflow will be to directly insert components into assemblies, mate and design around third-party data, just like any other SOLIDWORKS component. The second will be to directly open a PTC Creo file as a base derived part, and then add existing SOLIDWORKS features to that third-party design data. In this first scenario, we're going to work with a battery pack that was designed in Autodesk Inventor by a supplier and directly integrate that into our control module and mate it into place for proper fit and function. Back in SOLIDWORKS, let's take a look at the system options that enables to enable or disable 3D Interconnect. Under Import, there's a checkbox that allows us to enable 3D Interconnect. In selecting the file formats supported by 3D Interconnect, there's this other available options that allow us to include solid or surface body, reference geometry, or custom properties and material properties that can be used for bill of materials. Let's go ahead and insert the component just like we would another SOLIDWORKS part or assembly. Or with 3D Interconnect, you can see that we can directly insert file formats from other CAD systems, such as this Autodesk Inventor assembly. The icon in the tree looks slightly different to let us know that this assembly and its child components are being referenced directly to an Autodesk Inventor assembly and its parts. We can also see the file or the reference geometry here that can be used for mating. In addition to the reference geometry that can be used for mating, so can the faces and the edges of the model. With our bracket designed in context, we'd like to mate this as well to the battery pack to get everything in place for the proper fit. As always, changes take place, but this time they're going to take place in the native CAD system and overwrite the existing files that have been referenced by SOLIDWORKS. To simulate that change, we'll jump over to Windows Explorer, and I'm going to copy the modified file inventor files, the parts and the assemblies, and paste those directly over top the files that are being referenced. Back in SOLIDWORKS, after a quick rebuild, we can see that the icon in the feature tree has changed, showing us that the model needs to be updated. And that can be done by simply updating the model and reloading the modified files. And here we can say that the change has been processed inside of SOLIDWORKS with minimal effort, maintaining any and all mates to faces, edges, and reference geometry. For this next example, we're going to open the part directly as a derived base part. File type this time will be a PTC Creo. And what's different about Pro E is that every time there's a file is saved, it gets a version number. And 3D Interconnect is intelligent enough to handle these versions. When a file has been updated, and just like with the Autodesk Inventor files, the model is allowed to be refreshed to the latest version. Back in SOLIDWORKS, let's open a file. This time selecting Creo Parts. And we'll select the first version of this gear. And we need to make some changes. We need to add a key slot as well as a slot for timing. And this can be done by using standard sketches and features. In addition, we could also use library features. Here again, it's really important to note that these features are referencing faces and edges of the model. When the model is updated, all of the sketch references will stay intact. As you can see in the feature tree, the first item in the tree is the derived base part that references the PTC part version 1. Below that are the features that we just created using our design library. With our part saved, we can now insert this component back into our assembly. As you can see, there's a change that needs to be made, but just like the Autodesk Inventor file, the changes are going to be made inside of PTC Creo. Again, we'll simulate this by copying and pasting version 2 of the PTC Creo file into the same folder where version 1 is referenced. After a rebuild back in SOLIDWORKS, we can see that the model can be updated. Just simply right-click and update the model to version 2. And again, here to point out, all the mates stay in place that have been referenced to edges and to faces, as well as the features and sketch entities. So to summarize this webinar and the 3D Interconnect technology, 3D Interconnect is a SOLIDWORKS technology that virtually bypasses the translation process with new workflows when working with native files from other CAD systems. This is allowing you to streamline collaboration with customers, supply chain, regardless of which CAD tools they're using. And as you just saw, it would also allow you to leverage the legacy design data in their native CAD formats, just as if they were native CAD files. 3D Interconnect is also intelligent, understands when CAD data is changed within a native design system by honoring face and edge IDs, property sketches, and reference geometry. Changes to files are updated just like changes to native SOLIDWORKS files. File formats utilized by 3D Interconnect also open significantly faster than traditional export and import processes when CAD geometry has been changed in the native CAD system.